Okay, ladies and gentlemen, continuing with our revision. If you are watching, you are a grade 12 learner, don't forget to subscribe and go and press the notification button so that when we post videos, you get notification, because we'll be posting videos for grade 12, all the topics. So please don't make a mistake and miss out. Subscribe, send the links to someone who's doing grade 12, bila V. Thank you. Okay, so we're continuing with static electricity. I want to give you a particular scenario which usually occur. Let's say we've got two spheres which have got point charges. These are point charges on a sphere, on spheres, right? Yeah. You find that this one is -4 microcoulomb and this one is 8 microcoulomb. So here is the situation. They say that the two spheres were made to attach for a while, then later on they separated. You see now, we have spheres, right? Yeah. Then the spheres are made to attach, then are separated. You know, when the sphere attach and separate, this is what will happen. The electrons are going to move. The electrons are going to move, so that the electrons that are this side are equal to the electrons that are this side. That's what is going to happen. So remember, protons, they don't move. It's only electrons that move. Even when we do chemistry, protons do not move. So what is going to move? The electron, right? You see, this one, it is negative. Why is it negative? It's because there are many negative charges which are electrons. It means this one, there are many electrons, right? Meaning that electrons will move from this one to this one, right? Yeah. So when we have two spheres, sphere A and sphere B, they are made to attach, then they separate. After separation, the charge which will be on this sphere A and the one that will be on sphere B, they will be equal. You understand, right? Yes. Okay. What I'm bringing home is that if sphere A and sphere B, they are made to attach and separate, what will happen? This, after separation, we will no longer have -4 and 8. We will have a number which I will show you how we get it. But what you need to know is that the charge that will be here, it will be equal to the charge that will be here after separation. So this is a psychological mistake that we make. Let's say they want you to draw the electric field lines after separation. A psychological mistake that learners make. They will draw the electric field line using -4 and 8, which is incorrect. Immediately they say sphere A and sphere B were made to attach and separate. You no longer look at these spheres as -4 and 8. They have changed. We will no longer have -4 and 8. Yeah. If we are told that sphere A and sphere B, they were made to attach and separate, it means this sphere, the charge on this sphere, will be the same as the charge on this sphere. Do you take note of that? Yeah. Do you see? Yeah. So if we are told that sphere A and sphere B were made to attach for a while, then they are separated, you become happy because you know that the charge on this one will be equal to the charge on this one. If the charge is equal to 2, this will be 2 and this will be 2. Both of them, they will be the same. If you are told that they are made to attach and separated. Are you learning? Yes. Okay. So how do we do that? We say that the charge on each, we say charge 1 plus charge 2 divided by 2. We'll get the charge which will be in each sphere after separation. So if we make these two to attach, then we separate them. It means we'll have minus 4 plus 8, right? Micro coulomb. We divide by 2, right? Minus 4 plus 8 will give us 4 divided by 2. We must not forget to write the units, right? It means at the end, what are we going to have? We are going to have this 2. We're going to have 2 micro coulomb. So it means, you see, it is positive, it is not negative, right?
Yes.
So what does it mean? It means that if 2 spheres were made to attach, then separate, each sphere will have a charge which is 2, positive 2. If they say draw the electric field lines, you don't go and draw the electric field line on these 2. Immediately they say they were made to attach. Then you know that from that point onwards, you no longer take the sphere as minus 4 and 8, but you take it as 2. So even the questions which will follow after that, you no longer have a minus 4 and 8, you have only 2. So the mistake which learners make when they are asked a question, they use what? These numbers. These numbers, they are no longer there because the sphere were made to attach an electron. They moved past each other, right? Until they have got equal number of electrons. So they are equal. Are you learning?
Yes.
So it means if they say draw the electric field line, what are we going to do? We're going to have a positive sign, right? Then you draw the what? The electric field line. The what? The electric field line. When you draw the electric field line, you know what must happen? The spaces, these spaces, you see these spaces? Because it is positive, they will repel each other, these lines, equally so. Meaning that the spaces between them must be equal. Don't just draw something which is very ugly, which doesn't have, I don't know, it's an ammoboid. It's an ammoboid. It's got a shape of a stone. Don't draw something. You hear me, right? You see what I did? I draw a line. I just avoided to draw it here. Then I continue with it here. I draw another one, avoided here. I continue with the same line. I draw another line. I avoided here. I continue with the same line. You understand?
Yes.
Then positive. Guys, you have a car battery. Have you ever removed a car battery?
Yes.
The positive gives what? The power, right? It means the power is coming from the positive, the red one, right?
Yes.
So it means from positive, the charges will be coming out. From positive, the charges will come out. So it means we need to show the arrows coming out. They are coming out. They are going out, right?
Yes.
Well, good. They are coming out, going out. You understand that?
Yes.
So positive, they go out, right?
Yes.
Negative, they get in. You understand?
Yeah.
Negative, they get in. So you can see this is, look, I didn't draw many arrows. You don't draw many arrows. I'm avoiding it to draw. If I can draw something that is wrong here, I know it is the one which you are going to take. So I'm avoiding to do that. Don't draw many arrows here. You draw one, see? One arrow. And it looks beautiful just like that. You understand? That's how you make your own drawing. Look, I have a positive 2. So if this is for positive, right?
Yeah.
This is for positive, it's for one charge. If they say draw the electric field lines between the two spheres, you know what will happen? I won't draw this. I'm just representing for you how you draw for positive, right?
Yeah.
If they say I must draw, now I must draw the what? The electric field between the two spheres. You see, now these two spheres, they've got a positive 2 microcoulomb, positive 2 microcoulomb. So if I want to draw for each sphere, this is what is going to happen. Will we have attraction or repulsion? We'll have repulsion, right?
Yes.
So this repulsion, you just make them to be just closer to each other. Then you make a drawing like this. You make a drawing like this to show that what happened here, they repel, right?
Yeah.
To show that in this way they will repel. Then you continue with your beautiful drawing. You continue with your beautiful drawing. Continue with your beautiful drawing. Continue with your beautiful drawing. So positive, they are coming out. So the first drawing, I just wanted to demonstrate for you how to draw the electric field around a positive charge. So if we are talking about these two spheres which were made to attach and separate, both of them they've got the same charge, which is positive 2 microcoulombs. So the electric field shape will be like this. Why do we have this line just being like this here? It's because there is repulsion, right? The light charges, they repel. So they are repelling. Did you learn? So if you have two charges on sphere A and sphere B, then you are told that the spheres were made to attach and separate. You do what? You become happy. Because when they attach and separate, what do? You say charge 1 plus charge 2 divided by 2. The questions that will come after that, if you are told that they were made to attach and separate, the question that will come after that, you no longer look at the sphere as the original, how they were original. You look at them as two spheres having the same charge. Because I know that they will tell you that the sphere were made to attach and separate, but you will still take them as -4 and 8. So that's the mistake that most of the learners make. But I'm sure you're going to avoid such kind of a mistake, right? Okay, did you learn? If the spheres, two spheres are made to attach and separate, you say charge 1 plus charge 2 divided by 2. You understand? You get the charge. That answer that you get, it is the charge on sphere A and charge on sphere B. They are the same if they are made to attach and separate. We are good, right? Okay. Let me just show you how to draw the electric field line when we have a positive and a negative. Let's just draw an electric field lines on this one. So it's another question, right? The sphere were not made to touch and separate. It is original. We've got two spheres which have got electrostatic charges, -4 microcoulombs and 8 microcoulombs. Draw the electric field line between the two. What is happening? We're going to have a negative and we're going to have a positive. Right? Then we draw the electric field lines, right? We make them nice. You see, I drew something like this at the top, right? I do the same at the bottom. So the shape must be the same. You see? It's the same, right? Then at the top, at the bottom. No need to draw many things, right? Then here I draw same shape just like this. Another one coming out. I can draw 3. You can see I'm drawing 3. Even this side you can draw 3 to avoid drawing something which is wrong. You can see that these spaces between these two, they are equal. Even these spaces between the lines are equal, right? Then positive, you see we have a positive. What will happen? Does charges go in the positive or out of the positive? Out. Meaning the arrows will point to the negative. Why are they pointing the negative? Because they are coming out from the positive. Then here they will be out. Then here they will be in. So this is how we draw the electric field lines between a negative and a positive, right? But between a negative alone, if we were to draw the electric field on one charge, which is negative, we just draw the lines. We just draw an X like, so that the shape it becomes radial. You can see the shape is radial and the spaces between them is equal. You don't just draw something which is ugly, which looks like this, will mark you wrong, even if it's a drawing. If these spaces are not equal, you draw line and you make lines to cross each other. Lines are not allowed to cross each other. If you make lines to cross each other here, we will mark you wrong. So make sure that the lines are not crossing each other and the spaces between they are equal, right? Then for negative, it's out. Then you draw something like that. For positive, oh, it's in. I'm sorry. For negative, it's in. It's not out. It's in, guys. It's negative, right? It's in. What am I? For negative, it's in, right? I'm sorry about that. It's in. You can see, nah? So negative is in. So this is how we draw the electric field lines, right? The lines do not cross each other. Pattern is the same. When two spheres are meant to attach, Q1 plus Q2 divided by 2, you treat each sphere as like having equal charges, and you treat it like that. You no longer go back to the original. We are fine for this aspect, right? We are going to the next aspect. Guys, don't forget to subscribe and share the links with your colleagues. We are going to the next section. Okay, guys, I want to emphasize that for the distance between the 2 point charges, it is always in meters all the time. The trick is they will give you the distance between the 2 point charges in centimeter. You need to know that the distance between the 2 point charges, according to the electrostatic force, according to Coulomb's law, it must be in meters, not centimeter. Convert that centimeter distance that you will be given into meters. Let's just revise conversion, data conversion. When I was doing grade 8, we were told that we say, King Harry died miserable death called Mrs. You put 1 0 0 0 0 0 1 0 0 0 0 0 1 0 0 0 0 1 0 0. It looks easy. Some people are failing to convert, and I won't take like side thing. This one is for meter. This one is centimeter, meaning that the difference between meter and centimeter is what? 100. This is 1. This is the difference between a centimeter and a meter. It is 100. So it means if you are given 10 centimeter, if you are given 10 centimeter, if you want to convert this centimeter to meters, you do what? You divide by 100. Why are you choosing to divide? Why don't you multiply? It's because when you move from the smaller unit to the bigger unit, the number that you must get must be very, very, very small. You understand?
Yeah.
It must be very, very small. small. So you need to divide. So when you divide by 1,000, maybe 100. What do you get? 0,1, right? It means 0,1 is equals to 0,1 meter is equals to 10 centimeter. So that's how you do it. It's very important. Inculcate this in your head. I repeat, the distance between 2 point charges, it is always in meters. If you are given it in centimeter, you are given it in whatever, you must convert it to meters. Meters. Danko. Okay. I want us to do a question and we practice by that question. The question that appears on your screen, I want us to treat it. The question that appears on your screen. So, you can see that number 1, it says, explain why the sphere were placed on a wooden stand. Why are the sphere placed on a wooden stand? Is that the wood acts as an insulator. It insulates, right? Or we can say that to prevent leakages. Leakages. To prevent leakages. So we are using a wood on those spheres to insulate or to prevent leakages of charges. As we know that a wood cannot conduct electricity, right? It cannot allow charges to pass through it. So that's the first thing. The second question, I hope you can see on your side the question that I've put on the screen. So we are told that sphere R and S are brought into contact for a while and then separated by a small distance. If we have two spheres, then the spheres are made to attach, then they are made to separate. I told you that you say charge 1 plus charge 2, you divide by 2, you are going to get the charge which will be in each sphere after separation. So we're going to have charge 1 plus charge 2 divided by 2. We have what? We have what? 8 microcoulomb plus minus 4 microcoulomb. We divide by 2. Our answer will become 2 microcoulomb. What does that mean? It means this time around, each sphere have got what? Charge of positive 2 microcoulomb. I said when I was teaching the content initially that there's a psychological mistake which learners make. If they tell you that the sphere were made to attach then separate, you do not treat the sphere the way they were originally. The positive 8 and negative 4, they disappear. We no longer have such. Meaning that the questions that will come underneath the scenario where two spheres were made to attach, you treat the sphere as if they are new. You no longer have plus 4, you no longer have minus 4, and you no longer have 8. You treat each sphere as having same charges, which is 2 microcoulomb. So take note from that. When you are told that two spheres were meant to attach and separate, it means the questions that will come after that, you no longer treat the sphere as you were given originally. It means each sphere has got a charge of positive 2 microcoulomb, and the other sphere have got a charge of positive 2 microcoulomb. So, the second question as it appears, it says that draw the electric field pattern due to sphere R and S. So, what is happening with sphere R and S? Someone will make a mistake and say sphere R is positive and sphere S is negative. It is incorrect. The spheres were made to attach and separate, meaning that both the spheres are positive. They've got a positive 2 microcoulomb. So when you draw, we're going to have a repulsion. We have a repulsion. This is the question of calculating the net charges when the spheres were made to attach. So when we draw the electric field, we're going to have a positive charge and a positive charge. Then they do what? They repel. They repel. So we just simply draw repulsion like that. It is positive. From positive, they are coming out. Positive, they are coming out. So that's how we draw it. Someone will make a mistake and draw and think that sphere S and R, they've got negative and positive. No, they have changed. We were told that they were meant to attach and separate. When they attach and separate, we say Q1 plus Q2 divided by 2. We calculated and we got a 2. Meaning that any question which will come after a scenario where spheres are made to attach and separate, we treat each sphere as if it's a new thing. Each sphere has got 2 microcoulomb. Anything that will come underneath, we treat it as 2 microcoulomb. We don't have a plus 8 and minus 4. We no longer have such because the sphere were made to attach. An electron moved from where they were concentrated and to the other side to strike a balance. Then we have the sphere having 2 microcoulomb, all of them. Then the question that comes after that, it says that draw a free body diagram showing the electrostatic force expressed by sphere 2 due to sphere R. The electrostatic force. How do we draw the electrostatic force? The free body diagram, not the electrostatic force. This is how we draw a free body diagram. We are given information. We are told that after R and S have been in contact and separated, a third sphere T on of charging 1 microcoulomb is now placed between them, as shown in the diagram below. Look at the question displayed on your screen. Then you can see that we have sphere R. Then we're told that T was placed between them. Then we have S. Remember, what did I say? I said that we no longer have R and S as they were given originally. Originally, we had the plus 8 R and minus 4S because they were made to attach and separate. It means for this one we have got positive 2 microcoulomb. For this one we have got what? Positive 2 microcoulomb. They're both positive. Then we said another sphere. We are told that another sphere, which is positive, right? It was put between them. Positive. It's positive 1 microcoulomb. So we are told that draw a free body diagram show the electrostatic force expressed by sphere T due to sphere R. So what will happen to sphere T? What will happen to sphere T? It is positive, right? Meaning that it will be repelled, right? So our free body diagram, we're going to have this. Then we have that. Simple. That's how we draw our free body diagram. This is the free body diagram. Understand? It means that this one will repel this one, this side, and this one will refer this one to this side. Understand? So that's what we are going to have. Then we come to the last question. We come to the last question. What is the last question? You say calculate the net electrostatic force experienced by T due to R and S. The net electrostatic force expressed by T due to S. So how do we go about that one? What we do, we calculate with R, T, S. We calculate the electrostatic force between these two. Then we also calculate the electrostatic force between these two. After calculating the electrostatic force between these two, then what do? We add the resultant of that. We add the result, not the resultant. We add what we'll get here. Then that will be the what? The net electrostatic force between the two. So how do we go about that one? We say F. My markers are misbehaving. We say S, not S. F is equals to K Q1 multiplied by Q2 over R squared. We deal with these two. For R, what do we have? K is constant. Check your data sheet. It's 9 multiplied by 10 to the power 9. Then all multiplied by Q1. Q1 is R, which is 2 multiplied by 10 to the power minus 6. To the power minus 6, right? Then we continue. What is T? Charge of T is 1 multiplied by 10 to the power minus 6, right? We divide everything. My markers are misbehaving. So now, what do we do from here? We are given that the distance between R and T is what? Is 10 centimeters. I've emphasized that we do not use centimeters, but we use meters. When we convert centimeters to meters, we divide by 100, meaning that we're going to have 10 divided by 100, which will give us 0,1, then we square. Right? Then, the second thing, this is the electrostatic force that T expressed due to R. Let us calculate the electrostatic force that what? That T expressed due to S. We do the same thing. We have K, which is a constant, 9 multiplied by 10 to the power 9. Then we multiply by, what is the charge on S? Charge on S is still 2 multiplied by 10 to the power minus 6. Remember they were made to attach and separate. Then because that means R and S, they've got the same charge. Then charge of T is 1 multiplied by 10 to the power minus 6. Right? Then what is the distance between T and S? According to what appears on your screen, it is 20 centimeters, right? 20 centimeters, we convert it to meter because the distance is always in meter. We convert it, what will we get? We get 0,2, we square. Then, what do we do? What do we do? To get, we must indicate the direction, right? Then we do what? We sum them, right? After summing them, it means we'll get the what? We'll get the net electrostatic force. Okay, danko. Tada! I'll come back. Okay. Now I want us to deal with electric field. Electric field on a point. Electric electric field on a
Point.
electric field on a particular point. This electric field is given by electric field is equals to K, right?
Yeah.
Which is a, what do we call K? It's a proportional constant.
Yeah.
K multiplied by Q over R squared. This is then for electric field, right?
Yes.
So now, someone will even be worried because of this formula. You can see that they've got the R squared, and from the electrostatic force, we know that the R is the distance between a what? 2 point charges, right?
Yeah.
And we start to stress that, what is the distance is between what? Because we have only one charge here. What is happening? You can see we have got one charge. We don't have two charges, right?
Yes.
So, this R for distance is between the charge and a point. A charge and a point. It is the distance between a charge and a point. Let's say we have got two spheres. We have got two spheres, right?
Yes.
Which are 0, 2 meters apart, right?
Yeah.
Then point X. We've got a point X. Can you see? This point X is 0,4. Is 0,4 away from this one. Let us call it charge B. With sphere A, sphere B, and a point X. And you see that. So they say, calculate the electric field which point X experience due to B. Right? Calculate the what? The electric field which point X experience due to B. What does that mean? It means that K is constant, right? Q is the charge of B. Q is the charge of B. Then R is what? The distance between B and this point X. You understand? That's how we apply this formula. You get it? Okay. They usually love to ask that, what is the net electric field? Net electric field. What is the net electric field at point X? What is the net electric field at point X? You know how we go for that one? We calculate the electric field between point B. We calculate the electric field that point X experience due to point B. Right? We put it down. We calculate the electric field which point X experience due to A. We put it down in that direction, right?
Yes.
Then we sum them. It will be the net electric field. You understand? Let's take it. Let me just give you an example. Let us do this one. We've got point X, right? Let us just, the question wants you to calculate the net electric field that X experience due to A and B. Calculate the net electric field that X experience due to A and B. What do you do in that case? This is what you do. You say electric field is equal to KQ over R. You calculate the electric field that X experience due to A. Meaning that you are going to have K, which is a constant. It is on your data sheet. 9 multiplied by 10 to the power 9. And please, you guys, you usually make a mistake. You don't open the data sheet. You write what is in your mind and you make mistakes. use the data sheet. Go back to the data sheet, open it, copy as it is. Even for a formula, go back to your formula sheet, open it, copy the formula as it comes from the formula sheet. Don't do your own things, right? Okay, 9 multiplied by 10 to the power 9. Then the charge of B, I didn't give the charge of B. Let's just use, we've got a 1 microcoulomb and a minus 3 microcoulomb. So it means if I want to calculate the electric field that when X expressed due to A, I'm going to have multiplied by charge. This charge is for A, which will be 1 multiplied by 10 to the power minus 6. Someone who just joined now online, they will say, where do I get the 10 to the power minus 6? That is microcoulomb. Microcoulomb, it means 10 to the power minus 6. If we have the NC, which is nanocoulomb, it will be 10 to the power minus 9. Okay. So what is the distance between X and A? Is what? Kids usually make a mistake, they will write 0.2. It is not. The distance between A and X is this distance from this X to this A. It's 0.2 plus 0.4. You see? And that will give us 0.6. Understand? We get 0.6. 0.6. Then we get the electric field for this one. Then we do the electric field that X experienced due to B, whereby we are going to have 9 multiplied by 10 to the power 9 multiplied by 3 multiplied by 3 multiplied by 10 to the power minus 6 over 0.4 squared. This is what I usually tell people. I tell people that, you see that this is negative, right? We don't write negatives here, but on the calculator, you write the negatives. Understand? On the calculator, when you punch the negatives. Because these negatives, they just represent only the direction. You understand? They represent only the direction. Then, after getting the answer for this one, surely this one and this one, they will not go in the same direction. Right? If we take positive as right, this one will get a positive. It means this one will be to the right, this one will be to the left. Meaning that when we add the net electric field, E net will give us what? We'll get EAX plus EABX, right? Whereby they are going to subtract each other because this one is to the left, this one is to the right. How do we know? This one is negative, this one is positive. Just that we do not write the negative here because the negatives, they indicate the what? The direction. We just punch, but we punch it on the calculator. Then we get the answer. Then we add. We got the what? The net electric field. That's how we calculate the electric field. We are going to treat questions. Now I'm still teaching you, revising with you content. The things that we did in grade 11. You understand these things of electric field, right? Because I'm about to teach you how to calculate the electrons. Okay.